let's put it away. Let's get our note sheets out. All right, guys, so we're looking at this here. Now, we did some multiplication yesterday, multiplying two things, these monomials, these one terms. And when we multiply straight across. So the numerators are going to be multiplied with the numerators. The denominators are going to be multiplied with the denominators. So since we have 6 and 9 on top, well, we're going to do 6 times 9. Well, I have x squared and x to the 5th, so those will be multiplied together. And we also have y times y squared. So we were multiplying like things together. Now on bottom, well, 3 and 2 are going to be like, so we're going to multiply those together. And we only have one x, and then we have y to the 3rd and y. And so I'm rearranging these because it's just putting the like terms together so we know what we're multiplying, yes? Now, yesterday we went on and multiplied everything together and then simplified, yes? Well, we don't have to do it that way. Do we see anything that multiplies or would simplify here? So 6 and 9 here, we can multiply them, yes? Would the 6 and the 2 and 3 simplify?
Yes, sir.
What's 2 times 3? Well, 6, right? So all of this here would become what? Just 1, right? Yeah, we can simplify here. We don't have to multiply these together and then simplify. If there's stuff that we see that simplifies on top and bottom, we can do it at this point. So we can look at this here. Well, one of these x's would simplify with one of these, yes? So that wouldn't be 2 anymore. It would be 1, and this x is gone, yes? Because instead of combining everything together and then simplifying out, well, we can just simplify this way, can't we? Questions on this here? Well, how many y's do I have on top here? 3. Well, this y to the 3rd, that would cancel out with these, wouldn't it?
Would that make them 1?
So this would simplify to 1. This is simplified to 1, 1. So what's left on top? Well, we have 9. X to the 1st and x to the 5th gives us x to the 6. And what's the only thing left on bottom? Y. Questions on this here? So, I mean, this is a little bit different way to do this because instead of trying to combine everything together and then simplifying, well, we're just seeing what's in common and cutting it all out. So any questions on this here? Now, the way we looked at this yesterday would have been doing 6 times 9, x squared, x to the 5th, y times y squared. 3 times 2 times x times y cubed times y. Because when we looked at this yesterday, we would have gone through and done 6 times 9, which would have given us 54. 3 times 2 is 6. X squared times x to the 5th would have given us x to the 7th. Y times y squared would give us y to the 3rd. And then we just have x and then y to the 4th. So we can combine these like terms like this here. And now we simplify. Well, 54 divided by 6, if we plug that in a calculator to simplify, we would get 9. And when the bases are the same, the x to the 7th and x, when the bases are the same, we subtract the exponents. So 7 minus 1 would give us 6, and it would be on top. Y to the 4th and y to the 3rd, well, 4 minus 3 is 1. So we can get to this here. Either way works. It's just canceling out what's in common on top and bottom. How do they simplify? Any questions on either one of these here? So let's look at this one here. So again, when we multiply what's on top with what's on bottom. So on top, I'm going to rearrange it because we have 3 times 6. Those are our like terms. We'll have x to the fifth times x times y squared times y squared. On bottom, we'll have 8 times 9. We'll have x times x cubed and y times y. We'll have our like terms being multiplied together. So is there anything we can simplify between the top and bottom? The 6 and 9, yes? So what's in common with 6 and 9? 3. So I can factor out of both. So if I factor 3 out of 6, I'm left with what? 2. And I factor 3 out of 9, I'm left with 3. So if I do that the way that we did the last one, I'm marking those numbers out, signifying I pulled a 3 out, I simplified those two down, pulled a 3 out of both. Well, if I pull or factor a 3 out of both 6 and 9, well, what's left with the 6 is 2, and what's left from the 9 is 3. And so I kind of signify this is what's left over. Questions on this here? Right, so we have 3 and 3 here, yes? Well, I can do that, and that leaves me with 1, and this is now 1. So we can do that multiple times. Now, looking at the numbers, is there anything else we can pull out? 2 and 8 both have a common factor of 2, yes? So what does the 8 become? 4, and the 2 becomes? Is there anything else I can do with the numbers? So on top, we just have 1, yes? So we'll leave that alone because if there's any variables, we won't put 1. But on bottom, what do we have? I have a 4, yes? Now, the numbers are kind of nice because if you're not sure and you want to double check and make sure, the calculator is nice with that. Because you can hit the fraction key, do 3 times 6 over 8 times 9, hit enter, and it'll tell you it's 1/4. So that's an easy way to check it. Okay. Now we can look at the variables. Now we have x to the fifth times x. So how many x's do I actually have on top? 6, right? Because x to the fifth tells me I have x multiplied by itself 5 times. And then we have 1 more, so we have 6 on top, yes? And on bottom, I have x times x to the third. Well, how many x's do I have on bottom? 4, yes? Anything or divided by itself is always signified as 1, yes? Now, what's kind of nice is we're going to simplify what's in common on top and bottom. It's really nice if what's on top has the same power of what's on bottom, because then they kind of cross out. X to the first and x to the first, those have the same power, so we can just cross them out completely. Yes, because x divided by x would be 1. And again, this is kind of how I simplify it, because I'm seeing what's in common on top and bottom and marking it out. Now, we have x to the fifth and x to the third, yes? So 3 of these will cancel out 3 of the ones on top, yes? Well, how many will I have left on top? 2. So these will cancel out completely, and how many do I have left on top? Well, I have 2. So I got to mark the 5 out and rewrite it as 2. Is this making sense here? It's making this a little bit easier. So this means that we have x squared left on top because we've simplified everything out. There's no x's. Our x's are only on top. Yes, we don't have anything left on top and bottom with the same variable for x. Okay, now we have y's. Well, I have y squared and y squared on top, and I have y times y on bottom, yes? Well, how many do I have on bottom? 2, yes? So would these 2 simplify one of these 2 up here? So this is gone and these are gone. So what am I left with? I'm left with y squared on top. And that's it. Questions on these here? Are we good with these here? Okay. All right, so now we're going to move on to these here. Now the multiplication of what we're doing is not really changing. It's now we have these polynomial expressions on top and bottom of the fraction. Now again, just like we did yesterday, how we had to factor, because we only had one, and we factored and simplified, we're doing the same thing here, but we're also doing it with multiplication. So before we multiply anything, we're going to need to factor. Well, 3x doesn't factor because, well, it's 3x. There's nothing else with it. There's nothing else we can do.
When we multiply, are we taking the 3x, we're just keeping them apart for now?
Yeah, so these two are going to be multiplied together as a whole. Now, before we multiply anything together, it's going to be helpful to factor. And looking at these two here, well, 3x minus 3x squared, we can factor that. Is there a, because we always start with what? Greatest common factor, yes? Is there a greatest common factor between 3x and negative 3x squared? Well, there is. It is 3x is in common with both of those, yes? So we can factor it out. Well, 3x factored out of 3x is, well, 1. Anytime it factors all the way out, we're left with 1. Now, the negative stays the same because we didn't do anything with the signs. 3 out of 3 simplifies out completely. If I take 1x out of x squared, I'm left with x, yes? So that wasn't too bad factoring that out. So we'll leave the denominator for a second. Let's go on and do the other numerator. Well, the 20 is negative, so the signs are what? Opposite. One's going to be positive, one's going to be negative. When the constant term or that third term is negative, the signs are always opposite. Now the factors of x squared are going to be what? X and x. Our factors of 20 are 1 and 20, 2 and 10, and 4 and 5. Which ones do we want to use? 4 and 5. And the 5 would be positive. 5 is going to be positive because the middle term is positive. We could actually check it and multiply through, and it will show that it is plus 5x. Well, doing those individually is a lot easier than if we multiplied those together, yes? Because doing 3x minus 3x squared, factoring that, and factoring x squared plus 20 plus x minus 20 is a little bit easier than trying to factor negative 3x to the fourth minus 63x squared minus 60x. The factors of this here are actually going to be, well, 3x times 1 minus x times x plus 5 times x minus 4, as long as I multiplied that all correctly. Because those will be the same factors. It's just it's a little bit easier to work when we're not dealing with the fourth term. Yeah, no, I missed a whole set of factors on that. I didn't do the x. So there'd be even more than that. Okay, now we have one last thing to factor here. And that's our x squared plus 4x minus 5. We still need to factor this. Now, because the 5 is negative, our signs are opposite. The factors of x squared are x and x. And well, the factors of 5 are 1 and 5. So would the 5 be positive or negative? Positive. Well, we want it positive because, well, if we want something to simplify, well, we already have an x plus 5, so it'd be nice if the other one was x plus 5. And it does work out that it is x plus 5. So any questions on this here? Any questions on any of this here so far? Okay. So now we can multiply them together. There's an easy way, and this might be a little mind-blowing, but We'll see. So one way that we can write these is multiplication. Y'all ready for this? Yes? There, we're done. I mean, when we multiply them together, they go on the same part. The numerators go together and denominators go together, yes? Well, we just combined them, right? But that's it. I mean, we can rewrite this if we want. Because if we rewrite it, it's just going to be 3x times 1 minus x times x plus 5 times x minus 4. They all just go together. The denominators, I'll just move the 3x out front. X plus 5 times x minus 1. So we just put them all together on top and bottom. Okay. So let's simplify. We'll do restrictions here in a little bit, but let's simplify first. So what's in common on top and bottom? And the 3. So the x minus 1, these here are close. They're real close, aren't they? So the x plus 5 and x plus 5 match up exactly. The 3x and 3x match up exactly. But the x minus 1 and 1 minus x, they're off because they're not the exact same, are they? Well, no. One of them, the x is negative. The other, the x is positive. And one of them, the 1 is positive, and the other, the 1 is negative, yes? Okay, I'm going to rewrite this just so we have it down. So we have 1 minus x times x minus 4 on top. And on bottom, we have x minus 1. Let's get a highlighter out. Try to get a highlighter out. Now, if only there's a way that I could switch the signs of both x and 1. Because if I could switch them, if I could make the x positive and the 1 negative, then those would be the exact same, yes? If there was only some 1 that I could factor out of both of those to fix this, or kind of, not fix it, but kind of switch the signs, that'd be nice. Well, what kind of 1 would we pull out? I can factor out a negative 1. And it works, and this works as long as the signs of what's inside, both of them are opposite of what's underneath. Well, try not to write in a highlighter. Because if I pull a negative 1 out, well, the negative x becomes what? Positive. And the 1 becomes negative. Well, now they're the same, yes? So now we can actually cancel these out, leaving us with x minus 4, actually negative x minus 4. Now, another way that we can kind of look at this or get around it is when we looked at the start, we had negative x squared because the x squared term was negative. Okay, most likely we're going to pull a negative out because the variable, that x, if I can keep it positive, I want to do that because it's easier to work with a positive x, a positive variable when it's the biggest power, than it is to have 1 minus x. Because if I can avoid that kind of set of parentheses, I'm going to try to. And they're most likely, if they're going to throw that in, they're going to throw it in because they want you to factor out the negative. Now, we need to figure out what x cannot be. We need to figure out our restrictions. And I was wondering about this the other day, and I checked on it this morning, and I was right. This is where me and the book disagree, partly because of the pure mathematician in me. The pure mathematician in me wants us to list all of the restrictions out. However, the homework is not going to make you do that. What the homework is going to say is that we need to list every restriction that doesn't show up anymore after we finish simplifying. So what that means is I'll add a page here. So 6 over x minus 4. If this was what was left, x minus 4, we wouldn't have to leave or kind of list the restriction for this here because it's still here. Yes? Because we can still see x minus 4. Now, if there are other restrictions saying that x cannot be 0 or 7 2/56, we would have to list those because they're not here anymore. But if there's a restriction that's left up in our final answer, we don't have to list it because it's there. We can see it. Yes? So here, when we look at the restrictions, what's going to make the denominator 0 are these three here. Are any of these three left? Well, no, all of them simplified out, didn't they? So that means I'm going to list all three. Now, if one of them was left, if we ended up having this here is our final answer, the x minus 1, I wouldn't have to list a restriction for it because it's still there. We can still see it. Questions on this here? It's almost pretty much they're saying, if it's there, I can still see it. We don't list its restriction. If it's not there, which because our final answer doesn't have it, we have to list all of them. So we have to list out our restrictions for 3x, x minus 1, and what was it, x plus 5. We have to list the values of x that are going to make these three equal 0. Now, for some of these here, it's not too bad seeing what value of x is going to make these 0. Setting these equal to 0. So what value of x is going to make 3x equal 0? Because what times 3 is 0? Well, 0. That's the only thing. So what's going to make x minus 1 equal 0? Well, we can solve it equal to 0 by adding 1, and it'll just tell us that x is equal to 1. And what about the last one, x plus 5? Negative 5. Because we can solve this if we need by subtracting 5 and seeing that x is equal to negative 5. These are the three values that x cannot be. Any questions on this here? We ready for the next one? All right. So we'll look at this here. We're going to factor and simplify. We'll multiply these together. And to do that, before we really multiply, we're going to factor to make it a little bit easier. We're going to multiply these together to make it a little bit easier to work with. Now, the first thing they're having us factor on top is our 5x minus 5x squared. Yes? Well, if I notice, the bigger exponent for these two is negative, isn't it? So if they're going to do the exact same thing they did to us on the one before, most likely I'm going to have to factor out our greatest common factor that's going to be what? Negative, because we see that there is a common factor of 5 and x, yes? Which is going to turn that x squared into just x, and the other one to just a constant, a number without a variable. Well, most likely, since the one that's x squared, we're going to need it to be positive, so I'm going to pull the negative out. Questions on this here? So if I factor negative 5x out of 5x, well, that would be 1. But because the negative, it's not just going to be 1, it's 1. Well, negative 1. because it was positive, and if I pull a negative out of a positive number, it becomes negative. Now, the negative and negative would give us plus. 5 factors out completely, and if I factor an x out of x squared, I'm left with x. Now, we don't normally write negative 1 plus x. We would normally write it as x plus 1. That would be kind of the proper way to write it. Would you all agree with that? We normally write variables in front. I would do this here because switching a sign and switching both terms at the same time, I think can be a little much at once. It'll get a little confusing on what's going on. Okay. Let's factor x squared minus 4x plus 3. So since we have plus 3, the signs are the what? Same, and they're going to match the sign of the middle term, so they're both going to be negative. Factors of x squared. Well, that's x and x, and the factors of 3 are, well, 1 and 3, yes? So we have 1 and 3. Now we need to factor x squared minus 5x plus 6. Since 6 is positive, the signs are the same, and they match the sign of the middle term, which would be negative and negative. Factors of x squared would be x and x. Now our factors of 6 are going to be 1 and 6 or 2 and 3. Which ones do you think is most likely going to work? I'm going to go 2 and 3. The reason I'm going with 2 and 3 is because, 1 and 6 could work, and 2 and 3, both of them, because we do have an x minus 1 down here, and we have an x minus 3, so there's a 50-50 shot there. Yes? Well, what is this one going to turn into? X minus 1, yes? So we do have that, so there's still a chance that it could show up again. Because we can try 1 and 6, and there's nothing wrong with trying 1 and 6. Now, if we check it, x times negative 6 will be negative 6x. Minus x will give us negative 7x. So it's a little too big. Minus 3. And x minus 3 and x minus 2 will give us our 5x. So they end up working out a little bit better for this one here. Now let's see what that leaves us on bottom. Well, that's just 5x. Questions on this here? Okay. Now we can rewrite these. So on top we'd have negative 5x. Here we'd have x minus 1, x minus 3, and x minus 2. On bottom we would have 5x, x minus 3, and x minus 1. So we just kind of written them all together. Now, do we have anything in common on top and bottom? Well, the x minus 1s would cancel. And the 5x would cancel. And when we cancel all that, all we're left with is what? Negative x minus 2, because that's the only thing that's going to be left over. Now, these 3 terms in the denominator all factored out completely. So we need to find out what values of x is going to make them equal 0, because none of these can equal 0. So we need to find out what number will make them 0, because whatever number that makes these 0 would give us 0 in the denominator, which we cannot have. Now we can set them equal to 0 and solve. Well, 5x equals 0. Well, we would divide both sides by 5. And it'll tell us what? That x is equal to 0. So x cannot be 0. For x minus 3, we would do what? Add 3 to both sides. It would tell us x is equal to 3. So x cannot be 3. And lastly, we can add 1. Tells 1, so x cannot be 1. So here it can't be 0, 3, or 1. So some of these aren't too bad. You can probably see most of these here, what would make them be 0. And some it will be helpful to actually solve it out. Any questions on this here? We good with these here? Yes? Okay. We're going to do this one here. And this one here is going to be the last one we do today. This will be the last one that we do today. There are some more that I want to look at, but I don't want to rush it and try to get them all done today. We'll finish this up on Monday. I don't mind taking 3 days for this. Well, this one here is kind of nice. The x plus 3 is already as simplified as it gets. The 2x squared, that's as simplified as it gets. So 2 of these here, we don't have to do anything with. Well, hey. They gave us x squared minus 25, yes? That's not too bad to factor, is it? Because that's going to be what? X minus times. The difference of perfect squares and kind of our sum and difference of trinomials, they're not as nice, but or sum and difference of perfect cubes aren't as nice as this, but the sum and difference of perfect squares are pretty nice to factor. They're a little bit easier. Okay. Well, that leaves us with just the last one to factor, 2x squared minus 10x. Was the bigger power out of those two already positive? Well, yes, the x squared's positive already, yes? So I don't have to do anything with the sign, unlike the last two. So I can just pull out a greatest common factor, which would be, what? 2x. So I factor 2x out of 2x squared, I'm left with x. Negative, because we didn't change the signs, or didn't do anything with factoring out a negative. If I factor 2 out of 10, I'm left with 5, and x factors out completely. So 2x times x minus 5. Any questions on how we factored this here? Now we can multiply these together. On top, I'm going to have 2x times x minus 5 times x plus 3. On bottom, I'm going to have 2x squared times x minus 5 times x plus 5. Too far. So we get this here. Okay. Now looking at this here, is there anything that simplifies out of the numerator and denominator? X minus 5 and x minus 5. What else? So the 2x, the 2, but the x's don't simplify out fully in the denominator because we have 1 on top and 2 on bottom. So 1 and 1 will simplify out, leaving us with just 1 on bottom. Any questions on how we simplified this here? So what's left on top? What's left on bottom? Times x times x plus 5. So this here is what I was kind of talking and hinting at earlier when we talked about restrictions. Now the mathematician in me would still want to list every single restriction that's there. Now the textbook, what they're going to say, and it's not that this is wrong, it's just how we look at it. is saying that x and x plus 5, the restrictions for those two we do not have to list. We don't have to list them because they're still there. We can still see them. Now, the one that we will have to list, get a highlighter, try to get a highlighter, is this one here because x minus 5 factored out completely. We don't have it anymore. So here, so what would make x minus 5 equal 0? What value of x will make x minus 5 equal 0? 5. So x cannot be 5. Now we said one of the x's simplified out, yes? What would make that x equal 0? Well, 0, wouldn't it? Because it's x by itself. Well, wait a minute. Is that still listed? Well, this x's restriction is still 0, so I don't have to list it because it's still there. It's still present. Does that make sense? Yes? Kind of, sort of? It'd be similar to saying, and I used this reference earlier, kind of talking about pop figures. Because I have these here. I also have more at home. Because even though that these still appear here, I still own them, yes? So at home, if we wanted to keep track of it, I would need to make a list of what I have here so we know the total list that we have, yes? It'd be nice to have so that if your significant other is getting you Christmas presents, they don't order one that you already have or do it twice. She did that this year. I don't know, it's more embarrassing the fact that I opened it up, got excited, because I'm like, this is cool, I got one. And then went to put it up with the rest of them and realized, hey, this is already here. I didn't realize. But that's the kind of thing, because if it's already listed, it's nice to see we can find it. So on the answer for this one here, they're just going to have this here. They're not going to have us list the other two restrictions, because 0 and negative 5 are also restrictions. But we don't have to list them here. Now, when we start solving, because we will start solving these, having all the restrictions is going to be helpful. Because if you remember back to Algebra 1 or last semester, we talked about extraneous solutions, because we found numbers that worked, but when we plugged them back in, they didn't work for the solution or kind of the equation we started with. That's where these are going to be helpful. Because if I solved this and found that x was 0, negative 5, or 5, we know already it does not work because it's one of our restrictions. So it helps us so that we don't have to check as many numbers at the end. But we're a little ways off from that.